As a last step before we run the model, we have to now create an initial condition, and if you have open boundary, also an open boundary condition file. Now this is quite simple at this point because we already created a climatology file. If we go in ROMs and C files, we do ls of asterisk clim asterisk. We have already a climatology file that has temperature, salinity, geostrophic velocity, and so forth for our 12 months. And so we can actually use these values to produce a climatological initial condition, for example, and climatological open boundary conditions. Now the way we do that is there's additional scripts here. In particular, there's one called main underscore nc file underscore init.m that is used to produce this initial condition, and main underscore nc file underscore obc.m, which is used to produce the open boundary condition file. So let's start with the first one. So this first script is pretty simple. It has this initial block of code which says that if you have not defined the variable nameIt, which is the name of the grid that you're working with, then it just executes this. And in this case, we are just starting from scratch, so we're going to execute this part of the script here. I'm going to go in a MATLAB window, ROMs and C files, fire up MATLAB, and type F12. So by executing this block of script, now we have defined also the initial condition file name and the climatological file name. So that's all very good. The next step is to create the initial condition file, an empty one, which will be used then to store the values of the climatology. So we'll just do that. Oh, when I was pasting this, I didn't select disp very well, so this was an error. It needed a D, but it just displays what it's doing, which is creating an initial condition. After that, you have two options. One, for example, use climatology, which is what is equal to 1 in this case. And if you do that, then what you do is you have this 2 lines of code, very simple. And what this function does, this RNC set init from clima, it just sets the initial condition from a climatological values. And the inputs here are GRD, which is the grid. CLM file is the climatology file. Init file is the initial condition file where you're going to store the climatological initial condition. And time index is the time record that you want to use from the climatology file to store into the initial condition. In this case, I chose time index to be equal to 1. So I'm basically taking the January climatological value and storing it into the initial condition. So then you can just execute this part of the script here, and you're basically done. If you do an ls minus rtla, you have here your initial condition, and in fact you can execute directly the script as it is, and it will just do everything for you. Okay, so that's that. Of course, you can always modify this script, and suppose that you wanted to do your own initial condition, and this is an example just to get you started. What you could do is you could load a control array for the initial condition file. Well, first you create it here. The next thing is you can load, for example, the sigma layers, and then you can, for example, provide a temperature analytical function that is a function of depth, say, a function of an exponential decay. So actually, you could just do this, for example. Edit MATLAB, sorry, this MATLAB here, and you do that, and then you could just store the temperature with the RNT value here, and so oops, I forgot to initialize CTLI, so let me do that. Let me actually just copy the whole block here. We put it here in MATLAB, and then you save the temperature, and you can do the same for other variables or whatever you like. And in fact, I just left here blank, so you could fill in the blanks if you want to, or you could do other types of initial condition. This is just an example of what you could do. Okay. Now, similarly, for the boundary conditions, we have this main nc file obc.m. Okay. And this has, again, this initial block here, which is similar to what we've seen so far, except that now you define here the boundary condition file name. Then there's a second part that creates an empty boundary condition file. And then here you have a piece of code that uses the climatology. In other words, it takes the climatological values at the boundary and puts them in the boundary condition file. It's a very simple thing. And in fact, this script also you could just run interactively. Well, you could just run directly here by just typing OBC, and first I have to clear everything. Sorry, and I'm going to run the script here, and it basically does that for me. And so now I also have here an N Pacific boundary condition file. Okay, so again though, keep in mind that you may want to, what this does is basically produces, let's actually look at this boundary condition file. All it does is basically for every boundary it just produces these variables called salt west, salt east, salt south. For each boundary it has a field of salinity, temperatures, velocities, and so forth. And basically it takes the values for these particular boundaries from the climatological file directly. Now you may want to change these. For example, when we will do the nesting, we will produce open boundary condition files that take their values no longer from the climatology, but from time-dependent runs of larger scale models. And so we'll revisit this particular open boundary condition once we get into the nesting. And this, for now, we'll just leave the climatological values, which would get you started. So this is all for initial condition and open boundary. Thank you.